So let's take a look at the video. तो अभी तक क्या समझ आई आपको? What did you see? What was happening? Which was the fixing eye? Which was the deviating eye? And what does this patient have?
Right emulated system.
So you're saying that and this patient has a right esotropia. Okay, let's take a look at this again. ज़्यादा पीछे करूँगा तो उस पे आंसर आ जाएगा. All right. So 36, yes. Achha, take a look at what is happening. Has this eye moved? Does the left eye move? That is my first question to you guys. Okay, take a look at the left eye. Take a look at the left eye. इसको मैं बड़ा कर सकता हूँ? Yes, full screen हो जाएगा. ठीक है? Take a look at that left eye. So the left eye moves towards the left. That is the first thing which is important. Let's see what happens. Okay, the left eye has moved towards the left after he's put the cover. Now, after removing the cover, what do we see? The right eye is deviated inwards. Left eye is looking straight. I think this is the fixing eye at the moment, right? This is the fixing eye. But what happens? One blink, and again, the patient moves his fixation from this eye to this eye. Now, when he puts the cover in front of the other eye, does this eye move?
No.
No. Okay, the right eye is not moving. So ये controls थोड़ा समझना क्या रहे हैं? एक second. Yes. Let's take a look at this again. Okay. At the first time he covered the right eye. Now he covers the left eye. When he covers the left, okay. बाकी exotropia वाला next time हम देख लेंगे. Now over here, he covers the left eye. The right eye does not move when he removes the cover. The right eye remains in the same position. So my question remains the same. What does this person have? चलो थोड़ा हम दरमियान में सवाल कहते हैं, ठीक है? थोड़ा सा पीछे चलते हैं. Which one of the eyes is the fixing eye? इतना मुझे बता दो.
Left.
Are you thinking the left is the fixing eye? अगर left fixing eye हो, तो if हमने जो squint का कल last time algorithm discuss किया था, let's take a look at the algorithm again. So in the algorithm, in Hershberg's test, after we find that there's an obvious squint, this person has an obvious squint, इनके आप reflexes देखते हैं आगे पीछे थे, not properly aligned. और एक तो हम थोड़ा rights देख रहे हैं तो we're not able to judge. So let's just say that this person has a squint. They have an obvious squint. So when we cover the fixing eye, other eye it moves or it does not move. It moves and takes fixation, and we remove a cover. Then either there must be a recovery movement or there will be a fixed मतलब वो फिर वही आंख फोकस करने लग जाएगी. Okay? Remember the algorithm कि अगर फिक्सिंग आई को आप कवर करेंगे दूसरी आंख मूव करेगी. हम इस एग्जामिनेशन को एक बार दोबारा देखते हैं. Keep the algorithm in mind. Take a look at the algorithm. Understand this. Let's look at this again. Isotropia तो आपको समझ आ गया. Now, it's difficult to tell which one of the eyes is the मतलब is deviated, क्योंकि Hershberg's इतना हमें सही तरह समझ नहीं आ रहा. We can see that both the corneal reflexes there is somewhat nasal. तो हम Hershberg's को अभी साइड पे रख देते हैं, ठीक है? We do not know the Hershberg's result, but performing cover and cover we can say. So he is about to cover the right eye, ठीक है? As soon as he covers the right eye, the left eye it moves outwards. What does this tell us? इससे हमें क्या समझ आती है?
Right is the fixing one.
Okay, yes, that is correct. We are understanding that this person was using her right eye to fix. As soon as we block the right eye, left eye has moved to take fixation. That is correct. So what happens when he removes the cover? The right eye is deviated inwards. It is still deviated. It's not the recovery movement. It's still deviated behind the cover. And the left eye is still maintaining fixation. However, after a few blinks, you can see a person nystagmus हुआ है. ये आंख बाहर की तरफ गई है. It tried to go back, but it again came towards the left. Focus on the right eye here for a moment. Okay, it tried to went back. It again maintains the relationship. Okay, this patient has not yet blinked, but as soon as they blink, what happens? The right eye it moves outwards, and the left eye it moves inwards. Therefore, meaning that the right eye has again taken up fixation. The right eye is her main eye, fixating eye, which is focusing. As soon as it covered, there was good vision in the left eye. हमें पता लग रहा है कि all right, इसका fixation अभी ठीक है, इसका macula respond कर रहा है. As soon as this was covered, it took up fixation. However, as soon as the dominant eye, the preferred eye, the fixing eye was uncovered, it tried to gain back fixation. The patient blinked, and the right eye it again got fixation. Now, what happens when we cover the left eye? Does the right eye move?
No.
No, the right eye does not move, meaning that is the eye which has taken up fixation, right? It's already fixed. So, and when we remove the cover, there's no nystagmus भी कोई नहीं है, कोई jerk movement भी नहीं हुई, and after the patient blinks, okay, blink पे खत्म हो गई, but this patient does not blink, and the right eye still remains the fixing eye. So what does this patient have? Again, that is my question. चलो इसको थोड़ा simplify कर देते हैं. Which is the fixing eye?
Right.
Right is fixing eye. इस पे तो किसी को कोई शक नहीं है ना? इस पे कोई confused है कि which eye is the fixing eye? Is it clear to everybody that the right eye is the fixing eye? Is the eye which is fixating, which shows the preference in this person who has obvious squint?
भाई अगर राइट फिक्सिंग आया है तो उसको कवर करने पे वो क्यों डेविएट किया है? उसकी तो हम लोगों ने जो थी यानी कि जो इनपुट जा रहा था वो तो हमने बिल्कुल ब्लॉक कर दिया है. तो वो किस चीज को देखने के लिए इनवर्ड मूव किया है?
That's a good question. So when we discussed comment and squint, we said that कि input pathway में मसला आ रहा है, output दोनों eyes को बराबर जा रहा है, right? So there's we know that in squint there's an abnormal relationship between both the eyes. So what happens is कि अभी देखें ये relationship है. This is the relationship right now in normal. When we remove the cover as over here, right? When we remove the cover, तो cover डालने से पहले क्या हुआ था? We can clearly see that after we've introduced the cover, this eye moves towards left. ऐसे ही है ना? तो अगर output बराबर है तो सिर्फ ये आंख तो नहीं move करेगी ना सिर्फ. This eye will also move. So if this eye has moved towards the left, this eye will also move towards the patient's left, and that is what happens. It moves towards the left. because in comitant squint, the abnormal relationship is maintained in all directions of phase. Okay, so that abnormal relationship जो start में था cover and cover से पहले वो अभी भी maintain हुआ है. So as soon as this patient blinks, ठीक है, right now, अब देखो, ठीक है, his left eye is moved towards the right, and his right eye has also moved towards the right. That abnormal relationship is still maintained. ये हो क्यों रहा है? Because this is the right is the fixating eye in this patient, right? This is the normal fixating eye. And the left eye, if this is a fixating eye, then the left eye is the deviating eye. Now, when we cover the fixating eye, the left eye, it deviates or now it moves to take up fixation. That is what happened in this case, in this image. The left eye has movement to take fixation. However, as soon as we remove the cover from the right eye, fixation was transferred to the normal eye. Okay, the normal eye was the one with the better vision, जिसमें suppression नहीं है. The patient subconsciously, he wanted to fixate with his right eye, and hence the right eye, it made a recovery movement. ये जो आपको भी नजर आ रही है. So this patient whose right eye is the fixating eye, दोबारा this covering the other eye, it reinforces this. Okay, and when we cover the left eye, the right eye does not move because it has already taken a fixation. Okay, it has already taken a fixation, and when we remove the cover, there's no recovery movement, meaning the right is the fixating eye in this patient. So if right is the fixating eye, and we saw when we covered the fixating eye, the other eye, meaning the left eye, it moved to take up fixation. And when the cover was moved from the right eye, the right eye again moved to take up fixation. So this patient has left esotropia. आपको ये समझ आ गई है? Are you guys clear with this? अगर ये समझ आ गई है तो we can move forward. Otherwise, I'll repeat it.
भाई एक्सोट्रोपिया नहीं होगा?
एक्सोट्रोपिया.
अच्छा नहीं, ठीक है.
इसो का मतलब अंदर होता है ना, तो इसने तो लिखा हुआ है इसोट्रोपिया, बट आपको ऐसे बता देता हूँ. देखो कि when the eye is covered, in order to fixate, the eye moves outwards. यानी कि फिक्सेशन के लिए आउटवर्ड जा रही है आई. ऐसे है ना, फिक्सेशन के लिए इट्स मूव आउटवर्ड्स. एंड द रिकवरी मूवमेंट, ये हेट्रोफोरिया वाली रिकवरी मूवमेंट नहीं है, आप उससे कंफ्यूज ना होना. ठीक है, इसमें हमें पता लगता है कि अच्छा फिक्सेशन लेने आ रही है, बट एज सून एज द गुड आई इज अनकवर्ड, दैट आई अगेन मूव्स इनवर्ड्स. नॉर्मल रेस्टिंग स्टेट में हमें पता लग गया कि ठीक है, लेफ्ट आई इज इट्स नॉर्मल कंडीशन इज इनवर्ड्स. सो दिस इज लेफ्ट esotropia. So this patient has left esotropia. तो थोड़ा सा ये था कि I wanted to show you ताकि आपको clear हो जाए. So I hope things are clear. अगर नहीं समझ आई, if you have not understood it, do let me know. Lecture के end पे हम दोबारा discuss कर लेंगे, no problem. So last time we discussed an algorithm. This algorithm is easier क्योंकि Hershberg test में आपको पता लग जाना कि obvious squint है या नहीं है. So it becomes a lot easier to understand this test. Not sure of the Hershberg test, आपके पास कोई as such नहीं पता हुआ तो थोड़ा सा मुश्किल होता है इसको समझना. But even then, it's still possible. All you have to do is see if there are movements. अगर movements हैं तो there is a squint. Then you have to check fixating eye कौन सी है, उसकी movement क्या है, constant relationship and all that stuff, right? So this is a pretty good algorithm which tells us a lot. So last time we finished with this algorithm. We discussed a lot of things. Before we move on to the case and the treatment of pathophysiology, I wanted to discuss a little bit about binocular vision. Interesting. So I wanted to discuss binocular vision. Hershberg, दरअसल जब हम Hershberg's perform करते हैं ना, तो we are sitting directly in front of the patient. And like in this child, we're sitting directly in front. आप बिल्कुल सामने बैठे हुए हैं और जो torch है या source of light है, which you perform using to perform the Hershberg test, it's immediately in front of you. So the patient is focusing on infinity या torch पे, आप distance से छोड़ा. In this video, we're actually seeing the patient from the side. आपने थोड़ा सा गौर किया होगा कि जो examiner है, if you can see his reflection over here, this is the reflection of the examiner in this cover. So we're sitting towards the right of the examiner and to the left of the patient. That is why we're not able to properly appreciate Hershberg's test. अगर हम बिल्कुल examiner की position पे बैठे होते, तो it would have been a lot easier. The camera is probably situated towards the left. ये I think camera का stand है. If you can मतलब थोड़ा सा spin investigation अगर आप करना चाहें, तो that's why the Hershberg's test is coming a little bit थोड़ा side पर आना. It's difficult for us to interpret. So moving on, grades of binocular vision. What are the grades of binocular vision? And before we discuss the grades, what is binocular vision? Binocular vision क्या होता है?
दोनों आइज की जो इमेजेस होते हैं वो फ्यूज करते हैं और हमारे माइंड में एक इमेज बनता है दोनों आंखों से देखने वाला.
ठीक है, that's good. That's good concept. That is a grade of binocular vision. So basically, when we talk about binocular vision, we talk about three grades which encompass binocular vision itself. Ocular means eyes, binocular means both eyes. Vision means to see, so seeing with both eyes. It's simple enough, right? So there are three grades of binocular vision, and first grade पहले होता है, फिर second होता है, फिर third grade होता है. So these are different grades. The first is that there is bilateral macular perception. So you will say that a person has binocular vision if both of the macula means fovea, fovealis, all that part, has light perception. If light falls on that place and it can be perceived, that is the first grade of binocular vision. Second grade is there is fusion. I think second grade is fusion. This is the second grade of binocular vision. Now the third grade of binocular vision is stereopsis. Stereopsis किसे कहते हैं? Depth perception, right? It's depth perception. So if I were to visually represent this, 3D view, exactly. आपको पता हो कि what is depth? How can you perceive depth? That is third grade stereopsis. So if I were to visually show this, this is what the right eye is seeing. This is what the left eye is seeing at the macula. And if the patient is able to see this, then we can say that fusion is present and the patient has grade 2 binocular vision. So अगर मैं इस टेस्ट में कह रहा हूँ कि the right eye has to see this and the left eye has to see this and the patient's brain must superimpose the image so that he sees this. तो थोड़ा सा आपको समझ आ जाएगा कि in order to assess the binocular vision in a patient, we must have an instrument in which we can give different stimuli to both the eyes of the patient. आपको ये बात समझ आ रही है? What I'm trying to say. Let's say we have an instrument. Okay, this is one tube of the instrument, and process को कर लेते हैं. This is one tube of the instrument. This is the second tube. So if the patient looks towards through this tube, अगर यहाँ पे उसको lens लगे हुए हैं जिसके अंदर से देख रहा patient. So if he's this is the right patient's right eye is looking into this tube, this is the image they're seeing, right? And if the patient's left eye is looking into this tube, this is the image they're seeing. इसी तरह हम independent दोनों आँखों को हम images show कर सकते हैं ना. We can give them independent stimuli. These are the
मैं अभी लेक्चर ले रहा हूँ.
घर वालों को म्यूट करके बताएंगे आप लेक्चर ले रहे हैं, ठीक है? So as I was saying, at this मतलब in order to give both the eyes different stimuli or separate stimuli, independent stimuli, we must have an apparatus in which we can give individual images to both the eyes, and then if the patient he is able to superimpose these images, एक right side पे आ रही है, एक left side पे आ रही है, but he's able to superimpose the images in his brain, he sees this, then he will have binocular vision. So such an instrument is required in order to assess binocular vision. तो यही basic principle है एक instrument का, which is used to assess binocular vision and this is used to train binocular vision. Do you know what that instrument is? That instrument is called a synaptophore. A synaptophore is a very important instrument. It's important in the context of squint. Why? Because synaptophore की working इसी तरह ही है. This is a diagram of the synaptophore. इतना मुश्किल नहीं हम बनाते, but it has two different tubes. थोड़ा सा in order to compensate for the length, they use mirrors ताकि reflection हो जाए. So one eye of the patient looks into the right tube and the second into the left tube, and both of them see different images. They're not seeing the same thing. However, the patient is able to combine both these separate images and able to produce a slide, able to produce this third image, and we will know, okay, all right, this patient has fusion. So synaptophore, it tests binocular vision. That is the first important thing. The second important thing is, what if the patient is not able to combine these pictures? What can we do using the synaptophore? We can train him using the synaptophore so that his binocular vision develops. So the synaptophore is important in two senses. Number one, it tells us about binocular vision. It assesses binocular vision. Number two, it trains binocular vision. And this number two part is very important. How does it train binocular vision? What is this training called? Enter मुझसे लास्ट में पूछ लेना, because I always forget. मैं कहता हूँ enter बता दूँगा. I hope enter बता दूँगा इस बार. So let's move on with our case, the first case of the series. A 4-year-old child is brought to you by his mother with complaint of crossed eyes. हाइपरमेट्रोप मैंने लिखा हुआ है, ये मैंने एग्जामिनेशन में आपको बताना था. So this patient is brought to you by his mother. He's 4-year-old and his mother says that he has crossed eyes. So the first important thing, you take a torch, you shine it in the patient's eyes. This is Hershberg's test. On Hershberg's test, what do you see?
Left eye is deviating medially.
Yes, the left eye is deviated inwards. This is normal condition without any cover or uncovering, right? Left eye is deviated inwards. How can we tell left eye is deviated inwards? Bilkul, this is esotropia. The Hershberg's reflex is present between the limbus and between the pupillary margin. The temporal side पर है. अगर reflex temporal side पर चला गया है, तो इसका मतलब है eye अंदर move कर गई है. This patient has left esotropia. आपने दूर शुरू से देखनी है, but we know that we have people of science and we will always follow algorithms and perform a complete workup. So what is the first thing that we need to do?
Visual acuity.
You will perform a visual acuity. Now, when you perform a visual acuity, you get to know that this patient is hypermetropic. Hypermetropia, both eyes. कितना hypermetropia हम इस patient को देते हैं? Let's say he has around 4.5T. He has plus 4.5T hypermetropia in both his eyes. What's the second thing you want to do? क्या आप करना चाहेंगे?
Extraocular movement.
Extraocular movements, EOM. When you do the extraocular movements, you find out that, all right, eye movements committed है. Eye movements committed है, इसका क्या मतलब है the apparent gaze which we saw and immediately at the start, जिसकी basis पे हम Hershberg's test कर रहे हैं, that deviation, it remains constant in all directions of gaze. This is very important because it tells us if this child does not have a left medial rectus palsy, he does not have any motor problem, he does not have any myositis, he does not have any localized restriction which we're not able to immediately see in this picture because the movements are concomitant. So extraocular movements are concomitant, and Hershberg's test shows that there is left esotropia. What next would you like to do? आपके पास diagnosis आ गया? Do we have our diagnosis? Cover and cover तो करेंगे, but my question is, do we have our diagnosis?
Yes.
We have our diagnosis. So the question arises, why do we need to perform a cover/uncover test? अगर हमारे पास diagnosis है तो हमें क्यों करनी? That is my question.
दूसरी आंख को चेक करने के लिए.
दूसरी आंख को चेक करने के लिए. You're absolutely right. Cover and cover test. So cover and cover test tells us what is the condition of this eye, because we discussed 4 possibilities. If there is apparent deviation on Hershberg's test, हमें diagnosis मिल गया. We have to check the other eye. If the other eye, it moves to take a fixation, then it means that there is good vision in that eye. However, if it does not move to take a fixation, it tells us either the eye is immobile, we have to check again locally, the eye is blind, there is and light perception is 0, visual acuity is 0. Third is eccentric fixation has occurred, or there is abnormal retinal correspondence. The fourth is that there's a pseudosquint. There are other types of pseudosquint. होती हैं कुछ वो हमारे level से ऊपर. I don't want to talk about them because बहुत ज़्यादा मतलब unnecessary and unproductive discussion of it. So we have to check the condition of the other eye. The second is this patient can have an alternating squint. Alternating squint आपको पता था? बताया था मैंने? Yes, it's either uniocular, or it's alternating. That is also very important. We have to check that. So our findings on Hershberg's test, they can be augmented, they can be rejected, or they can be confirmed by cover and cover test. So cover and cover test tells us that this is a uniocular squint, alternating नहीं है. It's uniocular, and it's left esotropia. मैं उन 4 possibilities पे भी नहीं जा रहा क्योंकि वो हम उनको भी आगे डिस्कस करते हैं. Okay, so it's uniocular, it's left esotropia. So what is our final diagnosis?
Left esotropia.
Left esotropia. Our final diagnosis is left esotropia. Our final diagnosis is convergent squint. Our final diagnosis is concomitant convergent. These are the different names of a single clinical entity. Concomitant, convergent squint, convergent strabismus, esotropia, they all mean the same thing. So the thing is कि अगर आप
हाइपरमेट्रोपिया की वजह से जब कन्वर्जेंस होती है तो दोनों आईज में ही वो मूव अंदर यानी कि इनवर्ट मूव नहीं करती जब हाइपरमेट्रोपिया की वजह से कन्वर्जेंस होती है.
You're right. We have 6 minutes and I wanted to discuss the pathophysiology. It was my next question. Why is this happening? So you're right कि hypermetropia has a cause कि convergence होती है. So can you explain this कि क्या हो रहा है ताकि वाक्यों को भी पता लग जाए थोड़ा सा in simple terms, easier terms. Or does anyone know other than her कि why is
हाइपरमेट्रोपिया में वो लेंस की पावर को इंक्रीज करने के लिए वो होती है, अकोमोडेशन हो रही होती है तो साथ ही कन्वर्जेंस होती है। और बच्चों में चूंकि वो ज्यादा वो ससेप्टेबल होते हैं ज्यादा, तो इसलिए वो कन्वर्जेंस ट्विंट हो जाता है उन्हें, हाइपरमेट्रोपिया का ज्यादा हो।
हाइपरमेट्रोपिया ज्यादा, you're right. ठीक है, तो let me put it differently थोड़ा सा. In children who are hypermetropic, hypermetropia means farsightedness. They are unable to see the objects or the things which are further away. So, it was with eyes totally away. So, when a person who is unable to see objects which are close at hand, can he do anything which can increase the power of the lens so that the eye rays, हमें पता है हाइपरमेट्रोपिया में रेज जो हैं वो रेटिना से पीछे फोकस होती है, behind the retina, not in front, behind the retina. This is what happens in hypermetropia. But due to that, the person is unable to see objects which are immediately closer to him. So is there any way then that this person, the patient, he can increase the power of his eyes so that the light rays, they focus on the retina instead of being focused behind the retina?
He has to increase the effort of accommodation.
He has to increase accommodation. So basically, what is accommodation? आपने पढ़ा हुआ है. Accommodation is the increase in power of lens due to its shape. Lens becomes more globular, the power of the lens increases. But accommodation in itself does not occur alone, especially when we are looking at objects which are immediately close to us. Accommodation is a part of a 3-component reflex or a response. What is that response?
Near response. Pupillary constriction and medial convergence.
Yes, that is the near response. Near response हम में होता है, आप में होता है. It happens in everybody. Whenever we look at a distant object, आप आसमान को देख रहे हैं, and you're looking somewhere else, looking far off in the distance, then you're immediately going back and concentrating on what is right in front of you. It may be your mobile, it may be your laptop, it may be a book. What happens? First thing is there is accommodation. The second is pupillary constriction. Convergence भी होती है, pupillary constriction. The third is convergence. This is a 3-part response. हमें पता है कि बच्चे जो hypermetropic होते हैं, they are unable to see things which are close to them. So they will try to see, मतलब कोशिश वो ये करेंगे कि they see as much as possible objects which are immediately in front of them, and they will evoke this near response. This near response को वो ज़्यादा use करेंगे. What will happen? The child will accommodate. That will somewhat compensate for the hypermetropia. Because lens power increase हो जाएगी. The light rays will focus on the retina. But accommodation is only accommodation is required. However, the rest of the things they happen as well. Pupillary constriction जो है, it does not cause a problem. Okay? It's no issue. However, convergence is an issue because convergence means that both the eyes, they have to move towards each other. They have to move inward. दोनों अंदर move कर रही हैं. So होता क्या है कि this is the occlusion of the normal irides or the Cane's power. This is good. इस पे हम discuss करेंगे. This is a part of the treatment. I'm not sure in what context you've written this. So as I was saying, this near response is very important because a child who is hypermetropic, when he evokes the near response, what happens is that he accommodates, he converges, and he has pupillary constriction. However, sometimes or after excessive use of this mechanism, what happens is that the convergence, it becomes uncontrolled or even excessive. उसमें ये होता है कि excessiveness शुरू हो जाती है. So the child is presented with a difficult choice or a dilemma. What is this dilemma? Which the child has to subconsciously choose. That is the first thing. कि वो hypermetrope ही रहे. He does not perform any accommodation. Okay? Even when he's looking at near objects, he loses his near vision and he only looks at far objects. That is the first choice this child has. The second choice is that he accommodates, and with this accommodation, he has excessive convergence. And when there is excessive convergence, he will have good vision in one eye. However, as you can see that due to excessive convergence, only one eye can be fixating if he looks towards far objects or if he looks towards any other objects. अब convergence अगर बहुत ज़्यादा होना शुरू होती है, तो one eye is bound to be further deviated inwards, and one eye can only be normal. So this is the choice which the child has to make. That he either sacrifices vision, near vision completely, or he sacrifices one of his eye. He sacrifices one of his eyes so that the other has good near vision and good far vision. So that is the choice which is presented. If you have not understood this choice, don't worry, think about it. I'll be back in a minute. I'm ending this session now.